let's look at the circuit for classwork 15, number 3. Just look at it a little bit and get you started here. So we have 2 loops, 2 sources. It's very much like what we had in the previous homework. And it asks us to find the 3 currents. Okay, and it's given us the definitions and the directions, so we have to write our Ohm's law and so forth, KVL, KCL, according to these notations. It didn't tell us the resistor voltages, so we're free to name them or orient them like gives us positive sign conventions. So we would just do something like this, because the current here is going this way, so we want the current to enter the plus side of the resistor. So the way I drew it, current enters the plus side of this resistor, plus side of this resistor, because it all goes this way. This one, current's going from right to left, so it enters the plus side first, plus side here. Right? And so we could go ahead and name these all. They all have they have. We could name them VA, VB, VC, and VD, VE. So we can write KVL easier, or we could just, as we write KVL, we could just do IR for each one as we come to it, right? So this one is I2, this one is I1, and this one is I3. A little small on the paper there. Okay. So let's just start writing some KVL equations, because we're going to have to solve the whole circuit to get any of one of these currents, pretty much. Looks like to me, yeah. So let's do KVL top loop here. So we'll just say start right here. So we'll have plus VB minus E1, because we're coming in the small side, right? And then plus VA, coming around, plus VC, back where we started, equals 0. So now writing these in terms of Ohm's law, VB is R2 times I2, right? So let's just write R2 I2 Okay, so we are rewriting this in terms of Ohm's law, and so we have VB is R2 times I2 minus E1 plus VA. VA is little r1 times I2, and then VC is big R1 times I1. All right, each one has to have its own V equals IR equals 0. All right, so now let's do another KVL for the bottom loop. And let's just start here. So we'll go around. The first thing we hit is negative VC. And then we come over here, we hit the minus. Oops, is that the minus? Yes, that's the minus. I don't know why it's oriented that way. The minus side of VD. And we'll hit the minus side of VC. Oh no, I have two VCs. No, that one was VE. I call it VC. Let's call this one VE since I already used that one up there. So that was VC, the same VC I used there. Yes. VD minus VE. And there are only three things in that loop equals 0. Oh no, I forgot my source. There are 4 things. Come in the plus side of the source, plus E2 equals 0. There we go. So rewriting those in terms of the IR kind of things. Again, VC is I1R1, big R1, and VD is R3, I think this is R3. R3I3, and VE is little R2 I3, and then E2 is E2. Okay, And that's 2 equations, but we have 3 currents, so we need 1 more equation. So we'll do KCL on the left, I guess. On the left node. And so what do we have here? In equals out. In equals I1. Out equals I2 plus I3. Okay. So we got 3 equations, 3 unknowns. We should be able to solve, right? We got 1, 2, 3. We have numbers for these, and so we can let's just rewrite this one. Big R2 okay. I don't see numbers. Well, I guess I won't do it in terms of numbers. I think I lost the numbers when I was doing my copy and pasting, possibly. Okay, so what do we have? We have the first equation has I2 and I1 in it. Second equation has I3 and I1 in it, and then we'll assume the other things are known. And this one has all of them in it. So when you have something like these circuits that we've been doing 2-loop circuits quite a bit, probably the easiest is to take one and solve for the one that's in common between them. Yeah, so I1. So solve for the other one in terms of that one. So we're going to solve for I2 in terms of I1, right? So I2 in this one we'll bring these to the other side. E1 minus R1 I1 to the other side, and then divide through by the factored out coefficients of I2, which would be capital R2 and little r1, if I haven't made any mistakes. All right, so I've got I2, and I'm going to take that and put it in here eventually, right? So I'm going to make this last equation have only I1s in it. So we've got I1, I2 in terms of I1 will go there, and then we're going to use 2 and solve for I3, right? So we're using this one. It's got just I3 and I1. So if we're going to solve for I3, let's take it to the other side. So we're going to have E2 minus I1R1 divided by what was the coefficient of I3 on the other side, which is big R3 plus little r2. All right, so now I can take this and put it in for I3 and solve. And so I think you probably have numbers for everything, and so you can take those numbers, put it in as numbers, and it won't be quite so messy, hopefully. And so then you'll have this third equation that will be only in terms of I1, and so that can get you I1 equals a number in amps. And that's what it's asking for up here. All right, so that would be the first part. And then once you've got that, you basically got it solved, because then you can just use the second part. Once you know I1, put it in here and use this one. Once you know I3, and put it down in the last spot. Okay, let's look at, I think 5 is another one that could use a little bit of hints. Let's just talk through it just a little bit, so in case you're having a hard time getting started. But very much same thing, right? We've got 2 loops in the circuit. We've got more sources. We've got more resistors, but those are given to us. And so really we're going to have 3 equations, 3 unknowns. And so just do KVL left, KVL, and then do KVL right. All right, so you get an equation here. It'll have I1 and those are hard to see. I think this is 1, 2, 3. I1, I2, I3 in it. So this one will have I1 and I3. This one will have I2 and I3. And then, so you'll need a third equation. So we'll do KCL, say at the top. That's where they're all drawn. And then you'll have 3 equations, 3 unknowns. And so I would just do the same process again. Eliminate I2 and I3 from the KCL equation. Anyway, solve these for one of the variables, substitute in, and solve it. Or you could do linear algebra, matrix math, however you like to solve it. But you do need to write out your equations clearly and explain how you solve them. All right. And then again, it's just asking for those 3 currents. So very much the same process that we went through for the other one. You would go through, or that I talked over for the other one. You would do the same thing here.